Greetings, fellow nerds. When doing chemical reactions, sometimes the acidity or the basicity is important. This is usually defined as pH, and measuring it can be very useful for getting a reaction right. Now, there are a few ways to measure pH. The cheapest, simplest, and most reliable is pH paper. We have this more advanced pH paper on the right. It consists of multiple strips of pH indicators that have different transition points. Just apply a small drop of the solution you want to measure to the strip. Dipping the strip is actually not the best way to use pH paper because you might contaminate your sample with the indicators used on the paper. Anyway, wait for the color change. And then compare the color to a reference chart to find the pH. For things like field work and quick measurements, this is great. For even greater precision, an expensive but high-tech solution is to use a pH meter. I got this expensive laboratory model, but you can get cheaper ones off eBay for about $40. It's not as good as lab-grade stuff, but it's still very usable. Another company that sells a broad range of pH meters at various price points is Omega Engineering. I put the link in the video description. Now let me show you its components. This blue cylinder is the pH meter, which houses all of the electronics to measure pH. And this plastic tube mounts the glass electrode. It's currently in a potassium chloride storage solution. Electrodes must be stored in a 4 molar solution of potassium chloride to keep the probe surface hydrated and active. Do not let them dry out, and do not store them in distilled water, as this leaches out the ions in the glass that make it work. Now let me show you the actual glass electrode. And here it is. This glass bulb is what measures pH. If you look inside, there is a metal wire. This wire is the inner reference electrode that measures the potential across the glass. Now, to measure voltage, you need 2 electrodes. So if I can find it here, there it is. Can you see that little nub there? That is the outer reference electrode. This electrode works with the inner reference electrode to measure the potential across the glass and determine the pH. For the glass electrode to work, you must immerse the electrode all the way up to this reference electrode. Otherwise, you'll get erratic and irreproducible readings if you don't. Now I'm going to dip the electrode into some distilled water to wash off the storage solution. So let's start taking measurements. But before we can do that, we have to calibrate the electrode. To do a calibration, you need to purchase these calibration buffer solutions. Buffer solutions are carefully prepared samples that have an exactly known pH. They are very cheap and a must-have for any chemist serious about the quality of their pH measurements. You can buy them from Omega Engineering as well. So here's a sample of the calibration solution. This particular one has a pH of 7.1 at 25 degrees Celsius, which is the current temperature of my lab. I'm putting it in the speaker because the vial can't hold the electrode by itself. Now I'm dabbing off the excess water. Be careful not to touch the glass bulb itself. You don't want to contaminate or scratch the bulb. Now simply insert the electrode into the calibration solution and give it a few minutes to equilibrate. As you can see, the electrode has drifted quite a bit since its last use, so we need to reset it. On an expensive meter, we can just press in the right commands. On these smaller ones, there is usually an adjustment screw or similar that we can use. Let me adjust this one here. There we go. We've now calibrated this pH point to its proper reading. What about other points? Let me get a different pH calibration solution and see if the measurement is correct. This solution has a pH of 4.01. As you can see here, the pH meter says it's off. The slope of the pH response is not correct. On a more advanced instrument, we can calibrate this new point and the onboard computer would automatically readjust the slope. But for this cheaper instrument, we don't have that kind of ability. If we readjusted this point, we would misadjust the previous point. Now this error is acceptable for many experiments as the change in pH is more important. But in part 2 of my video on pH measuring tools, I'm going to show you how to use a calibration curve to compensate for this error.